In a typical Next.js app, two heavy tasks are data fetching and rendering. On the server, when we try to fetch some data from a data source, Next.js will keep the result of the API call in memory so that during the request response pipeline, we can reuse it by calling the same fetch with the same parameters. Also, it tries to store them into some files on the server so it persists during the next request from other users if they want to access the exact same data. At the build time, Next.js tries to generate some static files such as HTML that are the rendered output of our pages, as well as some data requires to build the React tree and make it interactive. We call it the React Server Component payload. On the client side, when we soft navigate through different routes by using the link component or using the use router hook, it tries to get the React Server Component payload and keep it as long as users refresh the page or the cache expires. Now let's call each one of them one by one. The first one would be request memoization. The second one is data cache. The third one is full route cache, and the last one is client router cache. I try to help you to know caching in Next.js better so you will be able to interact with it more efficiently. The first type of caching is request memoization, and the way it works, whenever you are calling fetch or you are using the fetch function, it's going to be memoized during the request response pipeline. It means if I call a fetch here, until I finish responding to user, I can reuse and recall the same fetch with the same URL in different places in my React tree. And it will only call this API, this URL that I am going to pass only once. The second time I call this, it's going to reuse from the information that I've memoized. Even if you call this in different components at different levels in your React tree, still it's going to be called and invoked only once during the request response pipeline. And it is actually a best practice to fetch data instead of drilling down to your component. It's better to just simply call the fetch again. Of course, you can wrap it with different functions, that's fine. For example, here I have this blog service, and inside this I am calling this fetch with this API, with this URL. I can open it so you can see it. It's simply a JSON file, totally mock data, and I'm getting some kind of posts, and I'm returning a response. Now, if I want to use this service on my page, I simply call this blog post, and then I call this get blog posts, and then it will return a post for me like this. Now let me try to print them somehow. If I put a p number of posts, you can see 100 items are received. Now imagine I have a component. I want to render a component. I've created one already, and this component also calls the same service. Let me open it. As you can see, I'm calling the same function to return the same data, and it is totally fine. Of course, I could have done this by passing the posts here, by creating an attribute and passing it down. We call it drilling, right? But since it is at the first level, that's fine. But imagine this post or this blog component has another level of component, and that component is calling and requiring this data. This way, we have to drill down the props, right? But another best practice is just by calling this anytime we need. So again, I'm getting the post. This time I'm rendering them here, as you can see. So the duration of this memoization would be until we return the response to the users. But of course, this fetch function accepts some other props that I'm going to cover in the next topic. So the next topic is about data cache. And the idea behind it is, since fetch API itself will only memoize only for one request, what if I want to store it somewhere, somehow? So later in another request by the same user or another user, I want to serve the same data to those users. This is where data cache comes in. And to opting it in or enabling it, we have to set the cache as the second parameter of this fetch function to something called force cache. This way, the first time I call this, first I will memoize it in memory for the subsequent calls within that request. And also I'm going to store the response of this API in some files. By default, it will be stored in the .next cache, fetch cache. And if we take a look into these files, I believe one of these should contain this response, this JSON response that I'm getting. Let's take a look. If I open this one, probably this is the one. So the URL, let me make it bigger maybe. If I search for URL, probably this is not the one. Next one, no. I'm looking, by the way, for the same URL that I'm calling, which is this one. So I believe if I look for it like this, yes, that's the one here. As you can see, this file contains all the data that I have fetched with a JSON-like format. So if I change the language to JSON, you can maybe see it better. Format document. So the kind is fetch. The data itself, as you see, it includes all the headers and the body. And the body is encoded in base 64. Later, when it wants to decode, it just simply converts and extracts the JSON out of it. And it has this status and the URL, as you can see. And there's a revalidation time here. It means for how long this should store on the server. I think this can be, I don't know, a year or something. But also you can set this value in the parameters that you're calling. So if I pass the revalidation here, but in the next, it accepts some items called revalidate. I can set maybe 10. And let's take a look again. I believe I have to refresh or open it again. I think that was the one. Yes, this is the revalidate now. If I format the page again, I have to change the language to JSON and language format. So as you can see, this is revalidate and it is in seconds. It means after 10 seconds, if someone else, maybe another user after 10 seconds, calls this API by opening the page, it will again call this API for us. It will not read the data from the cache store. But if we don't specify the cache item itself, the cache entry itself here, it's not going to store them into the data cache. Because by default, its default value is default, of course. I can open it so you can see different values that it can have. So request cache can be default, force cache, no store, only if cached and reload. So by default, the default behavior is in the no store situation. So it means by default, it's not going to store anything for you and it only will persist within that request. But if you want to enable it, you go with the force cache, like what I did before, like this. There's another way to revalidating or making this cache stale or invalid, and that's by specifying the tags. So inside this next object that we pass as the second parameter of fetch on the server, by the way, this next only is available on the fetch on the server because Next.js has implemented an enhanced version of fetch that has some built-in functionalities such as this data store that I just mentioned. So by populating and passing some items into these tags, we can specify or label them somehow. So later we can call another function to only evict or remove these entries from the cache. For example, these tags can be posts or blogs. You might have another function somewhere with other tags. And then on my page, based on some logics, maybe I have a button on the page, I don't know. Maybe I have a route, a specific route, and with that route, in that route, I'm going to revalidate. I'm going to remove the cache entries. The way it works, I simply call revalidate tag, and I simply pass the tag that I want to be removed. So by calling this, it will remove those entries for me that exist in the fetched cache. This is a good way to stale or make the cache entries invalid. By the way, as you can see, it's complaining about an error because we are not allowed to call this function inside the React tree. And to fix that, usually we call this inside API routes. For example, I might have this function, this kind of functions, and calling them here is totally fine. It means if I make a post request to this API, in this case this is like movie, it will remove this entry from the cache for me. And that was it from the data cache. Now let's talk about full route cache. I believe I don't need this page anymore, so I can close it to make this VS Code bigger. If I try to build the project, it will generate some outputs for me. So let me first delete this .next folder and then by calling npm run build, you can see it generates it again for me. And inside this, it will generate some static files that can be served immediately as soon as I run the project and a request comes in. To do so, what I can do, I can simply search for this home page. So they might be in the server, then the app, and then index. As you can see, I'm looking for a home page, and I see the output of our home page here in the index.html. So end users can see and open this, not directly opening this because it needs some other assets, as you can see, like CSS, JS, and stuff. But in general, this is how full route cache work. If you don't have anything specific here, it will generate an output. We call it a static site generation or SSG, and it's considered as kind of caching in the Next.js. And also it tries to store something. We call it React Server Component Payload. And as you can see, it's next to my file, this index.rsc. Let me open it. And it has still everything that is required to build the React tree. If end users receive this, or actually in the browser, if you send this, React can regenerate the HTML and rehydrate it for you. And as you can see, it's also cached. It's generated here, and it persists forever until you rebuild the project. So these files will be regenerated. This is one way to revalidating it. Another way is if we have some sort of fetching that is time limited. For example, here I have set 10 here to revalidate the data, and I'm calling this function that fetches some data from me inside my page. So this page will only last and will be kept in this full route cache for 10 seconds. After 10 seconds, Next.js will try to reproduce and recall this fetch function and regenerate it for you. The other way that you can make this stale, this cache, this full route cache stale, is by setting and exporting something called revalidate. So const revalidate equals something, but I have to export it. This means this page will be revalidated after 10 seconds. It means after 10 seconds, if first user at second 0 comes in and fetch this function, it will be get from the page. And the next time after 10 seconds, if someone else requests the same page, since it's been revalidated in 10 seconds, it will serve another fresh data. You can set different numbers here. Also, to disable it totally, you can, instead of exporting this, export another constant called dynamic, like this. And the value that you have to set is force dynamic. This way, even if you try to cache here by setting some numbers or not setting number, it will store it for you. Still, by having this on your page in this route segment, it will not be cached at all. Also good to know that if you have any kind of dynamic APIs, dynamic functions on your page, it's not going to generate these files for you. And I've also mentioned this in the previous videos. For example, if you call functions like cookies, or we have headers function. If you have any kind of this function invocation on your page, this path is not going to be generated or considered as a static file, because it assumes that you have different values and maybe different headers, and based on them you are generating some outputs. So it can be different from users with different headers or different cookies. And this is the logic behind it. And that was it from the full route cache. The next topic is how does client-side router cache work. I've changed the UI a little bit so you can see homepage and shopping page here are linked. So by clicking on the shop, it will redirect me to the shop page, which is a simple page. I don't have anything special here, as well as for the homepage. And the links themselves are in the layout. So I'm using the link component to make the navigation here. First one is pointing to the homepage and the second to the shop. Now, if I run the project, but in the build mode, on the production mode, it means I have to first build the project using npm run build. And then npm run start instead of dev, because we want to run the build version of the project. Now it's running. If I refresh, you can see that I can navigate through pages, but here's the caching happens. These links, as soon as they become available and visible into the user's viewport, Next.js will try to fetch them under the hood. To see that how it works, if I go to the network tab, if I refresh, let's see, I should look for something called React Server Component, or RSC. And you can see it's fetching one request or one React Server Component because we are on the home page currently, and it's saw there's a link pointing to the shopping page. So it's trying to fetch the shop for me. So shop React Server Component, and the response would be, let me make it bigger. You can see that the payload has this React Server Component, which is enough to generate the shop page by React. So if I go to the shop page, that would be fine. Now if I go back to the home page, since it already has the React Server Component of the home page, it will not download anything from the server. So you don't see any requests in here. So let me attach it here. You can see it better. I'm on the home page. I go to home, from shop to home, and vice versa. I'm doing it all over again, but you see that in the request panel, nothing has been changed. And the reason is that React Server Component payload is downloaded first and it's cached now until I refresh. So if I refresh, you can see one request pointing to the home page, and the other one, React Server Component itself, is in the current page, which is shop. It's stored somewhere already. Now if I go to the home page, it will consume this one to generate the home page. And if I go to shopping page, as I said, we already have that React Server Component payload, and nothing will happen. This is how client-side router cache work, and it's helpful to give us a good user experience in terms of navigating through pages. So in a nutshell, full route cache helps us to generate some HTML and CSS and JavaScript output at the build time. And also for the user router cache, it will be used on the browser after getting React Server Component payload. That only happens while you are doing the soft navigation between routes. I think that's it. I tried to cover all the aspects, all the 4 types of caching Next.js. And if you have any kind of questions, feel free to ask me in the comments. See you in the next one.